Hi, and welcome to this section of the Calculus 1 Derivative Help Tutor. In this section we're going to learn how to take derivatives using what we call the product rule of differentiation. So in the last sections we learned how to take basic derivatives, and especially things that are added together were very easily done by just taking the derivative of each part and just adding up the results. We learned how to deal with the fact that when we have a function with a constant in front of it, we just take the constant out and then take the derivative of the result. So we're going to expand our horizons a little bit, our skill set, and start talking about what happens when we have two functions, two bona fide functions of x multiplied together times one another. And the answer might surprise you. It's not quite as easy as it sounds, but once you get a little bit of practice, it's very, very simple. Okay, so what am I talking about here? I'm saying that if we have two functions, we'll call them f and g, then if I'm going to multiply them together, it might look like f multiplied by g. Now these are not variables, these are actual functions. F could be sine of x. I haven't told you how to take derivative of sine yet, but we'll get there. This could be, f could be x squared. G could be, 1 over x cubed. They could be anything at all, any functions of x. When you multiply them together and then take the derivative of the product of them, we have to use the product rule of differentiation, which is the following. And I'm going to say it about 10 times because I want you to memorize it. This is what you do. You take the first function, f of x, and multiply it times the derivative of the second function. So first times the derivative of the second plus the second function times the derivative of the first function, f prime of x. Again, I'm going to say that about 10 different times. So I'll put a little dot here just so you know these are multiplied. It's implied. It's important that you really remember this because you'll be using the product rule of derivatives all throughout Calculus 1, Calculus 2, Calculus, everywhere, because it's fundamental. Think about how many functions you might have. X squared times natural log of x. Those are two functions multiplied together. X cubed times parentheses x squared plus 5. Two things multiplied together. Anytime you have two functions of x multiplied together, you take the first function multiplied by the derivative of the second function plus the second function times the derivative of the first function. Your book may have it written in a slightly different order. This is how I think about it, so I'm writing it this way. First times the derivative of the second plus the second times the derivative of the first. So it's really not that bad once you get into working some problems. But let's look at a real example. Let's say we have some function, composite function that has two guys, 2x minus 3x plus 5. Now, first of all, I want to say, in my general definition, this up here at the top, this is just the sort of the general rule, right? I used f and g to represent the two different functions. But, in most of the time when you're doing your problems, they're going to say f of x for your function. So you got to not be quite so literal. This f of x is not the same as this. It's just saying this function consists of two different functions multiplied together. Here in my definition, I was calling this f and this g. I could have labeled them anything I want. Usually in your book it'll be labeled like this, so that's why I labeled it that way. But basically, fundamentally, it's saying two functions multiplied together. First function times derivative of the second plus the second function times the derivative of the first. So if this is the first function of x and this is the second function of x, you proceed in exactly the way we've outlined. So we say the derivative of this multiplication is going to be the first function, 2x minus 3, times the derivative of the second function,